Munchausen is a psychological disease more so, even though, where you start faking diseases, you'll even make yourself
Like
sick
intentionally, or
to
you
get
just,
attention.
or
Yeah.
it just.
It's a mental illness.
Yeah, it's a mental illness. So you would like ingest something that would make you sick, so you go to the hospital, so you get a lot of attention. Munchausen by proxy is where parents do it to their kids.
Oh,
That
yes, I saw 2020 thing where she was saying the kid had
You
cancer.
just have to go off, I mean, if you're saying that's how they were diagnosing, you have to go off by the kind of ethical, believe your patients.
Well, you do, and then that was
How
the
do you know
thing.
if they're faking it?
Well, a lot of times the kids aren't faking it. The mothers will give them stuff to make them sick.
Yeah.
They'll overdose them on different things. They'll give them toxins. A lot of them overdose them on vitamins, all kinds of different stuff to make them sick. And so the signs and symptoms are there. So it's hard for the doctors to figure
Yeah,
out.
because I saw a kid that had like, he was 8, he had 20 unnecessary surgeries.
Yeah,
But
that.
how does a doctor not notice?
Yeah, when it's starting to be surgery, I would start to wonder about that. But there's one where that, in fact, it was just in the, I just saw a thing on it where this lady kept her daughter
I don't remember this
sick
one.
for ages because
Oh,
of the attention. And
the cancer one?
Money, yeah, something.
I saw that
Oh
one.
no, the murder one.
Isn't that-
Where the daughter found out later on, it killed her mom.
Yeah,
wasn't
it was,
that-
she had cancer. She kept saying she had cancer.
They
And then she ended up killing her
They
mom.
go-
Makes sense like that too.
Yeah, the Sixth Sense, yeah,
Yeah.
Yeah.
On one
Yeah.
of
They
them,
kill Misha Barton.
Yes. Yeah. Yeah.
All right, let's get through this right here. So this is called Koch's postulate. The Koch's postulate, Robert Koch was the first one to come up with etiology. He developed etiology, what caused the disease. So what Koch's postulate says, and they still use it today, although we talk about it in micro,
Yeah.
it's got to be modified somewhat now.
Yeah.
But in the past, under Koch's postulate, you have to be able to what?
Find the
Get
disease.
the suspected pathogen from every diseased animal that has that disease. You're trying to decide what's causing it and identify it, grow it outside the body. Okay? Every healthy animal must be free of the disease. Right?
Mm-hmm.
You must be able to grow it outside and then inoculate a susceptible organism. And every susceptible organism must what? Come down with the disease, and you must again be able to do what? Re-isolate it and identify it from every one of those test animals. Right? That, you can do that under Koch's postulate. You can then say that that suspected pathogen, in this case, this bacteria right here, was what caused this disease. Okay? Can you use it with viruses?
No.
No.
You can, you just have to, what's called modified, you have to modify it. Because a lot,
With the virus?
yeah, they still use it, you just have to modify it. You have to get rid of his absolutes, like chickenpox. I've had chickenpox, so I still have the what virus in me.
Chickenpox.
I still have chickenpox virus in me. I look relatively healthy, I know relatively healthy, I didn't say healthy. But, do I have active chickenpox?
No.
So that, under his original postulate, it wouldn't work because I'm healthy and I have the virus. But you can still use it, they just have to modify it a lot. The general principle still works. All right, so culture of bacterial media select,
What?
how much more do we have? Oh, we still have a lot, jeez, man.
Yeah, we're never gonna get to the test.
Put more in here than I thought. All right, let's get through this quick, 5 minutes. A culture, when you're gonna culture bacteria, bacterial media, those auger plates you're looking at, right?
Mm-hmm.
If it's selective or differential media, does anybody remember what those do?
Yeah, it tells you
What?
what kind of virus.
Selective, and then certain types grow and certain types not.
Good. Selective media is gonna select for a particular type of pathogen, and it's gonna inhibit the growth of other ones.
Mm-hmm.
If it's got high salt, only things that like salt will grow on it. If it's looking for enteric bacteria, it puts bile salts in the media. Bile salts inhibits the growth of other bacteria, right? Differential media allows things to grow, but they look different. Okay? Serology or detection of characteristic antigens. I'll talk about ELISAs and EIAs, I guess, later on. Those are just using antibodies that are made to a particular pathogen. Okay, if you're gonna get tested for HIV, how do they test for it?
Eliza.
They use an ELISA. So they take out some of your blood and they put it in a plate and they add antibodies to a particular protein the HIV virus makes. If the
Oh.
protein's in your blood, The antibody's gonna stick, it's got a thing on it that changes color, and if it changes color, that's a positive test, right? That's the way, but if the virus, you're not infected, you won't have that protein in the serum, the antibodies won't stick, right? Those are called ELISAs. EIAs are basically the same thing. Genomic sequencing and medical metabolites produced by the pathogen, this is gonna be PCR, or GCMS. But I wanna talk about PCR real quick.
Isn't it the most like commonly used now?
Yeah,
PCR?
because it's quick. How long did it take? If you got HIV, if you thought you were exposed to HIV in the 90s, how long did you have to wait before you could get your ELISA done?
A while.
Over 6 weeks, because it was actually looking for the antibodies that you made to the virus. Then they started looking for the protein produced by the virus, GP120. I think that took 3 weeks, 2 weeks to 3 weeks, 2 weeks. That's a long time to sit and wait, to sit and wonder, right?
There's a lot of anxiety.
There's a lot of anxiety. PCR does it in, they say 7 days. There's some people say they can do it in 2.
So then how do they, for the at-home test, I've asked you this before, like, but I don't remember.
The home tests,
It's like instant.
because, okay.
You said that they're probably ELISA tests.
It's
but-
like it's called a lateral flow strip test.
Mhm.
So it's, okay, pregnancy test, how do those work?
HPV.
You look for the hormone that's in the urine, right? So you pee on the strip and then you're either happy or mad or whatever it is. They do the same thing. Those are basically like ELISAs. They have antibodies in them. So when the fluid starts to move through the strip, it picks up the antibody. It moves in another part of the strip that's got the chemical in it that's gonna change color if the antibody moves with it. Does that make sense to everybody?
Yeah.
Okay, that's the way those work. That's probably the way those home test kits work. They're called lateral flow strips. Basically, a modification of the ELISA.
Those are really accurate too.
They can be. Some of them, it depends on how sensitive and specific the test is. Some of them are super accurate. Some of the early pregnancy tests were like, oh, no, it's nothing good. Uh-oh.
You also get like a false positive.
Yeah, false positive too, yeah. So it depends, it just all depends on the test. Some are really, really accurate, because in general, the antibodies and stuff are really accurate. So it kind of depends. All right, PCR, we're gonna go through this real quick, because you guys, this is getting into actual hospitals and clinics now, because it's getting cheaper and cheaper and easier and easier. Okay? PCR is you're looking for the DNA or the RNA. Usually it's DNA.
What does it stand for?
Polymerase chain reaction. So here's your target DNA. Let's say it's HIV that's in the cells. Remember I said it reverse transcribes into double-strand DNA and goes into your cells? That's what you're looking for. So this, if you're looking for HIV double-stranded DNA, you're gonna take out the cells, you're gonna extract the DNA, you're gonna make primers. If you remember DNA synthesis from 1306, you have those RNA primers. These are DNA primers, they're just artificial primers, but allows the polymerase to attach, right?
Oh, I remember.
So you're gonna heat it up, it's gonna break the hydrogen bonds, it's gonna separate, it starts to cool down. The primers, if they're the right ones, are going to anneal to the strand, the target strand.
The primers are the ones that kind of put it together.
They don't put it together, if you remember from DNA synthesis, DNA polymerase needs that free, got me saying that word, free 3' hydroxyl group, right? The primers provide that. So if HIV, let's say it's this little section right here, it's gonna be G, C, C, G, A. DNA polymerase can't just attach, right? So this primer right here that you made artificially would be C, G, G, C, U, oh, it's DNA, T, T. When it cools down enough, because of complementary base pairing, these things want to stick together, right? That's just the way they work. So when you cool it down enough, if the primers are the correct ones for the target, they're gonna anneal. Once they anneal, DNA polymerase can attach, it's called TAC, and it's gonna make a copy of each one. And now you heat it up again, and those two do what?
Same.
Melt apart, and other primers now anneal, and you copy it what? Again, and again.
What does the word
And
anneal mean?
again.
Sticks to?
Anneal means they
Attach.
complementary base pair.
Complementary.
So
That's
can you
what
have
it
the
is.
ligand strand?
Both, yeah, both.
On both?
Put on both. Because you don't have the lag effect, you're only making short little snippets of it. You're only making them, usually you don't wanna make them more than about 250 base pairs long. So you put it in here, and there are two different things you can do. You can either make enough, or you can, have you ever seen those little gels where it says, oh, this is the father, or this is
Yeah.
this is the criminal? Those are, ethynyl bromide gels, and so once they get big enough, you can stain the DNA, and if it's there, you can visualize it. The new ones are gonna make a detection probe, so in the middle, you're gonna make another light primer type thing that's got a fluorescent probe on it. It's gonna be CGG, AAG. It's gonna anneal, then you hit it with a laser and it's gonna do what?
Glow.
It's gonna fluoresce and you can tell then you're positive for whatever you're looking for. Okay? You just have to make enough copies that you can detect it. All right, guys, we're actually over, so